Okay, it's Monday, and you all did very well on the midterm exam. So everybody passed with good grades. Okay, you did a wonderful job. So we can put that behind us. We know enough about DC generators and motors, and we don't need to review that anymore. Okay, so but this week we start on a little bit more difficult. AC generators and motors, all right? But before we do that, we need to discuss how DC is different than AC. Okay, going back to what we have already learned. DC, using DC to create a magnet, all right? It creates a permanent magnet. The induction goes solely into producing that magnetic field. That magnetic field is a stored energy of that particular element. Okay. If we stored that energy, then we have to, if we stop that storing of the energy, then we need to release that energy somehow. Okay, because that energy can cause arcing. Okay. And we do that by using a circuit which basically is composed of a diode to make sure that we leak in the opposite direction of the current that was originally there, and use a resistor to slowly leak that out. We don't want it to be instantaneous, all right? Great sparking and stuff. We want to avoid that. Okay, so that's the DC method of energizing. The AC is totally different. Okay, AC is got reactance to it. All right, there's reactance, inductive reactance. That inductive reactance is caused because there's a changing electrical. Okay, the electricity changes with time. All right, because it changes with time, you get a totally different induced energy. That energy is stored and then brought back, stored and brought back. That was what we call a reactance. Okay, if there's a reactance, then part of the energy that's being used in working up that alternator is utilized in this reactance. And the other part of the energy is what we really get out, the work energy, all right? So in order to get work out, we have to put a lot more work into it. And that's what happens in AC alternators and motors, right? So how do we do that? Well, we already know how to get AC out of a simple generator. Okay, we've seen that. But in a simple generator, we were looking to get pulse DC. And we did that by using a commutator. Okay, so if we get rid of the commutator and put in slip rings, okay, if we put in slip rings, then we'll get AC out. Okay, so that's a simple way of doing. That's the number one way that was done to get AC out, is to just change that DC generator into an AC generator by using slip rings. Okay, but then it was found that it was better to do it a different way, and the different way is to change the geometry. Okay, for DC we had poles. Okay, we had poles on the outer, and we had coils on the rotor. Okay, here for the other way of doing it, for an alternator, we'll change that around. Instead of putting poles on the outside, we will put our coils on that outside, and we'll call that outside the armature. Okay, the stator armature, we'll call it. And on the thing that rotates, we'll call that a rotor. And the rotor is going to be full of coils, okay? What do those coils do? They actually magnetize the rotor. So you've got a magnet that's rotating here and crossing over into the stator coils. So the induction is from the rotor to the stator, okay? Whereas for DC, the induction was from the magnetic poles to the rotor, okay? Here it's opposite, all right? And that's what it's all about. So just remember, though, that we are talking about reactive inductive reactance. We're talking about I squared R work, okay? And the total work that we put into it is going to be more than the total work that we get out of it because of all the reactances. Excuse me. So that's what we're in store for today, and it takes a little getting used to it. Okay, so let's get ready and read through the stuff that's the lessons for today. Give me a call or send me an email if there's something that you don't understand. I will help you understand it. All right. So good luck, and I'll see you at 12:15.